All right, so it looks like the microphone's on this time. I already made this video once without it, so it's been a while. So let's get into this. I wanted to sort of clear up some stuff about these Fourier series and some of the things about functions from the past, Math 100 and Calculus 1, that we need to simplify these series computations. So first of all, note. There was a minor mistake on the worksheet I gave out Friday. I fixed it. And so now I've uploaded the corrected one on the blog. So either it's only one line, it's like the third line. So either fix the one you have or download a new one and print that out. And it wouldn't have changed anything on your homework, so no harm, no foul. So yeah, let's get into this. Let's let f of x be a function. And first of all, if f of minus x equals minus f of x, then f is odd. And if f of minus x equals f of x, f is even. And the two classic examples are sine is odd and cosine of even, right? So if you take the sine of minus x, it's minus sine of x. And if you take the cosine of minus x, it's cosine of x. Okay. Also, if f of x equals f of x plus t for some t, then f is periodic with period equal to t. So for sine and cosine, f of x equals f of x plus 2 pi. It just says that if you take a copy of the function on its entire period, you can keep copying it over, right? So if you take sine from 0 to 2 pi, you just keep copying this over and over again forever. Okay, so that's from Math 100. And here's some calculus. If f is odd, then the integral from minus L to L, and it's important that these numbers match, of the function is 0. So you're just computing area. So f of x equals x is odd. So if we look at that function here, the integral is represented by this area plus this area. But they're equal, so when you add them together, because one's negative, you get 0. In a similar vein, if f is even, then what? This is equal to 2 times the integral from 0 to L f of x dx. And now if you look at an even function like x squared, you can see that this area is exactly equal to this area. So in integration, it's easier just to get this area here and multiply by 2. And again, all these problems can be done without these tricks, but they definitely make computations significantly faster. And lastly, if you have an odd function times an odd function, it's even. if you have an odd function times an even function, it's odd. And of course, if you have an even times an even, it's even. And you can show all these quite easily. And so, okay, let's just do a problem that's really similar to homework, but it's not one of the homework problems. So if you follow this, you should be able to apply it to all the homework. So find the Fourier series for the function f of x equals 1/2 x on the interval -2 to 2, and f of x equals f of x plus 4. So the period now is 4. So in this game, 2L equals 4, so L equals 2. That's important. Okay, before we jump into computing Fourier coefficients, we want to ask ourselves, is f even, odd, or neither? If it's neither, you can still do it. You just have to do a lot more integrating. If it's even and odd, you get to use those lovely formulas to simplify things. And, well, let's check. Compute f of minus x. So that's 1/2 minus x, which is minus 1/2 x, which is minus 1/2 x. And this is f. So I get minus f of x. So f of minus x equals minus f of x. Therefore, f is odd. Okay, so now we compute the Fourier coefficients. It's 1/4 minus 2 to 2 f of x dx. And this equals 0 because f is odd. So an is 1/2 minus 2 to 2 f of x times so f of x is what? Where is the sheet? It's the an is cosine, so it's cosine of n pi x over 2 dx. Now, f is odd, and cosine of n plus 2 is even. And so odd times even is odd. Therefore, this is 0. Cool. So far we have a naught equals an equals 0. So that means all the work happens with the bn's. All right, so bn is 1/2 minus 2 to 2 f of x sine of m pi x over L dx. F is odd. Sine is odd. So the product is even. So now we get 1/2 times 2, 0 to 2, f of x sine n pi x over L dx. Okay. These two cancel and we get 1/2, 0 to 2, x sine n pi x over 2. This should be a 2 dx. So now we head over here to integration by parts. I'm going to use the Tableau method here. So we have sine of n pi x over 2. And I keep forgetting this, so I'm going to put a big parentheses out here and multiply by a half. Because this half, this is just for me to not screw up. So you differentiate on the left, integrate on the right. And so when you integrate sine, you get minus 2 over n pi cosine n pi x over 2. Integrate again, and you get minus 4 over n pi squared sine n pi x over 2. Okay, so let's set up our evaluation here. We have 1/2, not forgetting it, minus 2x over n pi cosine n pi x over 2 plus 4 over n pi squared sine n pi x over 2 evaluated from 0 to 2. Okay, we're close. If you plug in 2 and 0, this guy becomes 0. And then over here, the 2's cancel. So I have minus x over n pi cosine n pi x over 2 evaluated from 0 to 2. Remember, when you plug in 0, you get 0. So all we pick up is the 2 term. So it's minus 2 over n pi cosine of n pi. And we do an even odd argument because of the n's. So what is this? This is minus 2 over n pi for n even. And 2 over n pi for n odd. Okay, so here's the series. N goes from 1 to infinity. It's alternating, so I'm going to put a minus 1 here. Then I have 2 over n pi sine n pi x over 2. And the minus 1 gets a n plus 1 because we want the odds to be positive. So hopefully this is the right answer. Let's check. Let's check here. So minus 1, 2 over n pi. So let's check here. I'm going to go to Desmos. Turn this around here. We'll start with just 3 terms. So I've already graphed 1/2 x from minus 2 to 2 here. Start with 3. So let's see here. So minus 1 raised to the n plus 1. 2 over n pi sine n pi x over 2. And even after 3 terms, it's already starting to converge. Come on. Work with me here. There we go. So let's go up to 5, 7, 9. This is looking good. 23. And if we go to 100 or 200, it doesn't matter. It looks exactly like the function. So there you go. That worked out great. And hopefully I left the microphone on.